Advanced Financial Modeling, Topic 5, Fixed Income Portfolio Management. Learning objective number 4. We're going to use Excel's built-in bond functions. So when we calculate bond value, bond duration, and convexity before, we use some homemade or user-defined functions. However, Excel has some built-in functions for bonds. There's a price function, M duration function, which calculates modified duration, and a yield function, which calculates the yield to maturity. However, the parameters of those functions are a little bit different than the ones we've used. The main difference is it doesn't use maturity in years. What it uses is maturity date. So if you have a bond you bought today and it matures in 10 years, you don't put maturity at 10, you put in the actual date. And the settlement date is also required. That could be, say, today's date, or if you're going to buy the bond and it settles in 3 days, it might be 3 days from now. So you put a date that's pretty close to today as the settlement date, and you put in a maturity date in the future. The other parameters are the rate. Now it just says rate, but that's actually the annual coupon rate. There's the yield. That is actually the yield to maturity, or you can think of it as the discount rate. It also has a required parameter of something called redemption. Now, redemption is always going to be the number 100 for this course. Redemption refers to, at maturity, what percentage of the par is repaid to the owner. So we're just going to put it 100. Frequency is the number of coupon payments per year, so 2 for semi-annual payment, 4 for quarterly, and so on. And there's one other optional parameter which you can leave blank for this course, and that is basis. It has to do with how in finance you may have different ways of counting the number of days in a month for the computation of interest due. Okay, so we're going to go to the spreadsheet. We're going to use Excel's price, M duration, and yield functions and compare them to what we got using the user-defined functions. So here's our 30-year bond we worked on in the last section. It's a 30-year, 10% coupon, has a YTM of 9% or discount rate, par of 1,000, maturity 30 years, 2 payments per year. The price was selling for $1103.19, and we went ahead and we calculated the duration, convexity, and bond val. Let's go ahead and use the price function in Excel. So I'll click on my FX. I'll click on all and start typing price down here, and there's my price function. So it requires the settlement date. So I just made up some dates here. Say I bought this bond in January 1st, 2013. That's going to be my settlement date. Maturity date matures in 2043, so that's the 30 years. The rate is going to be the annual coupon rate. So I'll put the 10%. The yield is going to be that discount rate, 9%. Redemption, I will put in 100. And frequency is 2 payments per year. And I'm going to leave the basis blank. And when I do that, I get a price of 110.319. So this is what Excel's price function does. This bond is a $1,000 bond, and according to our models and just taking the present value cash flow, should be worth $1,103.19. However, Excel's price function always returns the price as a percentage of par. So it doesn't matter if the par is $1,000, $100, $10,000, or $1 billion. This price function is going to return a price of 110. And it's just following market convention. When you quote the price of a bond in the market, you wouldn't say this bond is selling for 1103. You'd say it's selling for 110.3. It's selling for 110% of par. If you actually wanted to know the actual price of the bond, you can take 110 divided by 100 and multiply times my par and get the 1103. All right, so so these match up. That's perfect. So let's go ahead and look at the M duration function. So there's M duration. I'll go ahead and put my settlement, my maturity, my annual coupon. Notice here it says coupon and not rate, so we'll put the coupon rate. the yield, which should be the discount rate. The frequency is 2 payments per year. And we'll leave the basis blank. And you see there is the 10.187 is the modified duration. Actually, if you read the description of the M duration function, you'll see that it actually says it's the Macaulay duration. It is not. It is the modified duration. And then lastly, the yield function. I'll come down here. I'll start typing yield. And I'll go ahead and put in my settlement. Maturity 1/1/2043. Now price. To get the yield to maturity, you need to know the price of the bond. Now, whoops, let's put the coupon rate back in there. Or sorry, the rate. And back to price. It says price is securities price per $100 face value. So this is asking what is the bond selling for. Notice here it was selling for 1/1/03/19, and we determined that was 110.319% of par. This is what required. You have to put in price. You need to put in 110.319. It's a price as a percentage of par. Redemption 100. Frequency 2 payments per year. Leave the basis blank, and there is that 9%. So if the bond is selling for 1103, it has a YTM equal to 9%. And that's the way we set up this bond. I picked a discount rate that's equal to the YTM, or in this case, the discount rate is the YTM, since the bond is selling at the present value of its cash flows. Okay, so that is using Excel's bond function, price, M duration, and yield. And the big things are, for those functions, the parameter of redemption is going to be 100, and the price is always a percentage of par. So in this section, we just talked about how to use Excel's functions, built-in functions. We'll start talking about effective duration and portfolio analytics in the next topic.